Have you ever looked at a really shiny, perfectly finished metal part, like a gear or a piece of hardware, and just wondered, how do they get that flawless, super durable coating on there? Well, it might seem simple, but creating that perfect finish is actually a pretty fascinating scientific puzzle. So today, we're going to break down the science behind that perfect shine. Okay, so think about an object that's got a ton of curves, sharp edges, maybe even tiny little holes drilled all the way through it. How in the world do you make sure every single one of those nooks and crannies gets an absolutely even layer of metal coating? That's the real challenge, right? And the solution is, believe it or not, surprisingly elegant. For engineers and manufacturers, this is what they call the pleating puzzle. A lot of the traditional ways of doing this just can't handle complex shapes. They end up leaving an incomplete or totally uneven finish. Imagine trying to spray paint a really intricate sculpture. It's almost impossible to get that paint to cover the inside of every little crevice without it just globbing up and building way too thickly on the outside edges. Well, pretty much the same thing happens with older electrical plating methods. They can leave these little weak spots and gaps, which you can imagine is a huge problem for high-precision parts. So, how do you solve a puzzle like that? Well, it turns out the answer isn't more power, it's actually less. The solution is purely chemical. And honestly, it's kind of brilliant. It's called electroless plating. Sometimes you'll hear it called auto-catalytic plating. Basically, it's a process where you just dip the object into a special chemical bath. Then, a super-controlled chemical reaction happens that causes metal to deposit itself perfectly and evenly onto every single exposed surface. And the best part? No electricity required. See, the big difference here really boils down to electricity. Traditional electroplating uses an electric current, and that current acts almost like a magnet. It concentrates the coating on the sharp corners and outer edges, but it leaves those inner crevices with a really thin layer. Electroless plating, on the other hand, is a pure chemical reaction happening in a liquid, which means it bathes every single surface equally, and the result? You get that perfectly uniform coat. It's just elegant and a whole lot simpler. And this chemical approach comes with a whole host of benefits. I mean, the even coating is the main star of the show, obviously, but the fact that you don't need electricity also makes the whole process cheaper and way more efficient. You don't need these complex setups, and you get incredible control over the thickness and even the final look of the coating. Now, while you can technically do this with other metals like gold or copper, the real industry standard is electroless nickel, or as you'll hear it, EN plating. So let's zoom in a bit and see how this specific process builds such a strong and practical coating. So what is EN plating exactly? Well, it's this really clever chemical process that deposits a super strong nickel-phosphorus alloy onto a part. Think of it like this. The object gets dipped into a water solution that has nickel salts in it, and then another chemical, a reducing agent, is added to kickstart a reaction that basically makes the nickel stick to the surface. Now, it might sound like magic, but it's actually a very precise and controlled process. So let's walk through the exact steps and see how a simple metal part gets its super-powered coating. It's really like a four-step dance. First up, preparation is everything. The part gets meticulously cleaned to make sure the coating will stick perfectly. Then, it gets dunked into the bath. Step 3 is where the action happens. This is the deposition. It's a slow, steady buildup of that nickel alloy. And finally, a quality check makes sure the coating meets the exact specs. Okay, so we get the science, but why does any of this matter? Well, this process isn't just some neat lab trick. Its properties make it absolutely essential for countless industries that we rely on every single day. The real value here comes from the properties of the coating itself. That nickel-phosphorus layer provides incredible protection against rust and wear. It's also way less porous and significantly harder than other coatings, especially after you give it a little bit of heat treatment. And all that just means parts last longer, they perform better, and they're far more reliable. So just how hard are we talking? On the Rockwell's C-scale, which is a standard way to measure hardness, an EN coating can hit a score between 68 and 72. Now, to put that into perspective for you, that is significantly harder than most steel alloys. We're talking about approaching the hardness of a high-quality knife blade. This incredible durability is exactly why it's the top choice for parts that have to face constant friction and wear. And because of those benefits, you find EN plating absolutely everywhere. In your car, it's protecting the gears and brake pistons. In aerospace, it's on critical rocket and satellite components. It's used in oil and gas, plastics, textiles. I mean, the list just goes on and on. It's really one of those invisible technologies that makes our modern world run. But maybe the biggest advantage, at least for manufacturers, is the precision. Because the coating is so perfectly uniform, it can be the final step in production. There's no need for extra grinding or polishing. The part comes out of the bath completely finished and ready to go, meeting the exact measurements every single time. So, the next time you see a piece of high-performance equipment, you'll know the secret behind its perfect, durable finish might just be a simple chemical bath. It really makes you wonder, doesn't it? What other incredible science is quietly at work all around us, just hiding in plain sight?